We always have disclaimers. The government shutdown still has limited my access to some map servers on the internet. I'm not sure why. Today, I will only claim that the internet made me say it a few times. My references are going now from the internet to personal experience. My experience with water is within the realm of engineering and geology. Empty. My canteen was never empty. I'm not a survivalist, so I can't give you any information on that. Today's topics include deserts, looking for water, surface water, springs, and the Colorado pipeline. Do you know what the two most frequent causes of death in the desert are? Thirst. How about the second one? Have you heard of flash floods? Some Indian tribes did not suffer flash flood fatalities. Do you know why? It was guessed, they believed that the evil spirits dwelled in slot canyons. So they never went there. So religious beliefs have some practical significance. What is a desert? Any ideas?
I've heard it's a place with less than 10 inches of rain per year.
Correct. Less than 10, it's an arbitrary definition, but it's less than 10 inches annual rainfall. 20% of the Earth's surface is classified as a desert. 2% are only 2% are sand dunes. Have you heard of the rain shadow effect? That causes most of the deserts. And there are differences among the deserts, which include seasonal moisture and characteristic vegetation. Annual rainfall in inches is color-coded. Green indicates high rainfall amounts. Which locations are shaded green? East of the Mississippi, the Northwest, and then the mountain areas, the Rocky Mountains, Sierra Nevada. That's where we have the most rainfall. Does anyone know why Southern California isn't green? I don't, but I think it's near the horse latitudes, and the horse latitudes are where there aren't much winds for sailing, so it has something to do probably with wind direction. But it is kind of an anomaly to see all this moisture along the coast, and all of a sudden it stops right here. So that's a homework assignment for next week. Someone tell us why there's relatively low rainfall in this area. Well, we just had a problem. Was within the desert area or had less than 10 inches of rainfall. This brown shade here is less than 10 inches. This is really desert. The red area is less than 5 inches. And let me get the pointer up. And then the tan area right here is less than 15. Here's the rain shadow effect. With increasing elevation, moisture in the air condenses. and falls, leaving the leeward side of the mountain dry. Do you know what leeward means?
Opposite side from the wind.
It's protected from the wind. And consequently, it's also protected from the rain. So that's why we have deserts. Armijo traveled during the winter. Average annual rainfalls and elevations are shown on the slide. Half the locations identified are technically in a desert. And Armijo traveled mostly downhill. So Victorville is a desert, Las Vegas is a desert, and Farmington get a little bit more rainfall in Kayenta and Hurricane. And for some reason, I couldn't find a St. George weather station, so that's why we're looking at Hurricane. And then LA is only about 18 or 19 inches, as compared to 40 to 100 inches up on the northwest coast. Elevations show he's going downhill, and then he has to walk uphill when he's kind of in the vicinity of Victorville. Well, this is a major problem. Here show typical variations of rainfall. Blue is rainfall, and red is temperature. January is to the far left right here. Armijo's travel time generally was during the rainfall season, so it was kind of December through January, except for Farmington. So Kayenta, kind of the wet season here. Hurricane, wet season. Las Vegas, rainy season. And we can see from these charts also, if he would have traveled during the summer, he probably would have got heat stroke. 100 degrees, this is the 90-degree line right here, 90 degrees. So Las Vegas would have been quite warm, as well as Hurricane. Victorville, wet season. And LA is actually wet season during the winter time. Can you name 4 different deserts located in the Southwest? Mojave.
Sonora.
Pardon? Sonoran?
Basin.
Yep, we've got them. Okay, so what's this right here? That's the Great Basin. How about this area? Let me get the pointer back up. Maybe the pointer might be causing us problems, but I hope not. How about this area right in here? Mojave. And this area right here, that's Sonoran. It's actually subdivided into Colorado and Arizona Sonoran deserts. Different deserts have different moisture seasons and characteristic vegetation. So we can see that in the Great Basin, the moisture comes during the winter, and it's cold enough where it comes as snow. The characteristic vegetation is sagebrush. Moisture in the winter for the Mojave, Joshua tree is the characteristic vegetation. Winter and summer in the Sonoran Desert, they probably have monsoons. And saguaro is the characteristic vegetation. Looking for water. Obviously, we can see water in rivers and lakes. North-facing shaded areas. What's the significance of north-facing?
Cooler, that doesn't evaporate.
Less evaporation. Locations where vegetation is different from the surrounding area. and dry riverbeds. I'm not a survivalist, but here are a few tips. Some cactus is a source of water, but they also may get you kind of sick. What happens when you wrap cactus in plastic? It sweats and condenses, so that might be a source of water. And most importantly, keep your mouth closed, do not talk, eat, smoke, drink alcohol, or eat anything salty. So leave the pretzels home when you walk in the desert. Can we use aerial photos to find water? What do we see? Sometimes when taking walks, I take my iPhone and I look at Google Earth. And then I locate which houses have swimming pools. And what's better than owning a swimming pool? Having a neighbor who owns one. I bet the county also looks at aerial photos to audit property tax. And if you didn't see them before, this highlights the pool locations. Where's the water? What's the source of water here? It's the springs. Okay, what's the source of water here?
Can you turn the lights on?
Oh, yeah, thank you. I'm sorry, I forgot. Ah, magic. Should we back up and start over? Okay, we've got springs here. What's the source of water here? It's rainfall. It's because of the higher elevations. Rivers and lakes and reservoirs are obvious sources of water, but we can see them on an aerial photo. What's the source of water here?
Irrigation.
It's a well for irrigation. We've got some vegetation here right in the drainage channel. Do you think there's water there? Okay. Is the vegetation any different than this vegetation? That's probably a good indication that if the vegetation is different in the stream channel, there may be water there, but if it's the same as the adjacent area, there's a good chance there won't be water there. What's wrong with Rio Grande River?
Too many rivers.
It's redundant, right? What does Rio mean?
River.
So what we have is the Rio Grande,
Big river.
not the Rio Grande River. Okay, which state has most been influenced by Spanish occupation?
New Mexico.
Okay. But let me show you a different way to measure that. Let's use rivers as an indicator. New Mexico has 79 rivers that start with Rio. Colorado only has 11, and several of those extend down into New Mexico. Arizona only has 2 Rios, Utah has none, Nevada 1, California 2, and surprisingly Texas only have 2 rivers which start with Rio. Do you remember the Geographic Names Information System database? I talked about that probably in the first class. Well, it only took 5 minutes to query this database to get this information for this slide, which is trivia, but
USGS?
no, it's U.S. Geographic Names. In the desert, does the amount of water in a river decrease with increasing distance from its origin? Maybe is right. Yes and no. Evaporation and infiltration decrease flow. Tributaries increase flow. Irrigation decreases flow. Irrigation channels are lined to prevent water loss. So as a river flows down its course, if it infiltrates, it will lose water. I think the Colorado actually has run dry on a few occasions before it reached the Gulf of California. Today, dams regulate flow, so it's a little bit more predictable. At some locations, dams on rivers may be of more value than controlling floods than providing irrigation or hydropower. Armijo's travelway parallels the Rio Grande in the circle area, in this area right here. As we've heard, it refers to Big River. It drains 3 states. The headwaters are San Juan Mountains. It discharges into the Gulf of Mexico. A typical or an average representative flow rate is 2,400 cubic feet per second. And again, depending upon the width of the channel, this you probably can walk across. According to one measurement, the distance is 1,248 miles. There are 15 dams along the main course, but none are famous. Do you remember where the disputed border was? That involved the Rio Grande. It was between the Republic of Texas and Mexico. It's a wild and scenic river. Like National Historic Trails, wild and scenic refers to national promotion and national protection. It's one of the principal rivers of the Southwest. This again is from the Geographic Names database. Other names or variant names, these names may only apply to segments, not the entire river itself. Variant names include the Rio preface are right here. We can see some names that may have Indian origins. Can you see a problem trying to use names of landscape features to find the way Armijo went? All he did was list names for landscape features in his journal. And if they change with time or have so many names in history, it gets to be quite a challenge to interpret his journal to find exactly which way he went. Colorado River is probably the principal river in the Southwest. Armijo's travelway is circled where he was in the vicinity. It drains 7 states, which is the shaded area. Rocky Mountain headwaters, and the headwaters being in Colorado, that's probably how it got its name. It discharges into the Gulf of California. Length is 1,450 miles. Its flow rate is about 22,000 cubic feet per second. This is quite difficult to walk across. So you got to pick your locations. Armijo picked the crossing of the Fathers. There are 15 dams along the river, and 2 of them are famous. What are the 2 that we remember? Hoover or Boulder and Glen Canyon. Okay, the interesting thing is, what does water generally do? It wants to run in a straight line downhill, the steepest path. But if we take a look at the direction the Colorado River flows, it's kind of along a straight line, which probably follows the overall general slope in the downslope direction. But we've got two surprises here. It quickly changes direction here, and it quickly changes direction here. First of all, do you know where this location is? That's the Grand Canyon. And there are several explanations. You've heard the story about two geologists looking at one rock. There were 5 opinions as to what its origin was. So geology is not an exact science. But there are several opinions here, but the one that I vote for is its overflow or spilling from a lake, that there possibly was a big lake here that overflowed and that kind of eroded and changed the direction. Also, I just recently found out that this overspill theory has offered as an explanation for this change in course right here.
What about fault lines?
That can control. I don't think it controls these two locations. But fault lines can control river locations. Here again is variant names, past names that referred to the Colorado River. And right here we see there were several rios. San Juan, Armijo's travel way is this red line right here. It drains 3 states. San Juan Mountains are the headwaters. It's a tributary or discharges into the Colorado River, 383 miles in length, 2,100 cubic feet per second. According to the journal, Armijo crossed this river at least twice. And then there's one dam. And it's located right about here. In the forensics class, we will look at why or why not Armijo didn't follow the San Juan. For me, it's a little more logical to travel along the San Juan than to go a distance above and then come back. But that's a forensics issue. More variant names, 2 more Rios, and some of these Indian names also appear on the Rio Grande variant list. And I'm not sure, does anyone know if there's a generic for river in different Indian languages? I don't know, but that may be a possibility. Virgin River, Armijo's travelway. It drains 2 states. Springdale is the headwaters. Do you believe that? It actually is from a name standpoint because that's the junction of the East Fork and the West Fork. So those are separate rivers. And the Virgin actually starts in Springdale. And of course the West Fork, I think headwaters is up near Navajo Lake. 162 miles in length, again, this is from Springdale. 180 cubic feet per second. That's pretty easy to cross. And there's maybe one dam. There's no reservoirs, no boating, no big recreation, but I think we can see an old irrigation dam up near Hurricane. It's also a wild and scenic river as of 2009. And I think 2009 was the centennial for Zion National Park. Again, there's a debate as to whether Armijo traveled through the Virgin Gorge or he went north of it. That's again something we'll take a look at in the forensics class. More variant names. Jebediah Smith traveled on the Virgin River, and he called it the Adams River in 1826. This is the USGS database or data set that includes a lot of information about streams and springs, and that has been my primary reference or resource. You can find it on the internet and just kind of do a Google search on national hydrography. Stream classification. These classifications are included in the database. Perennial, continuous flow. Intermittent, seasonal flow, so primarily snowmelt. And where you have intermittent streams, you generally have some base flow. Ephemeral, in direct response to precipitation, and generally there's no base flow. Perennial is derived from the Latin perennius, which means lasting through the year. Now I'm kind of reluctant to experiment with the pointer here because we may freeze, but okay, we'll take a look at this strip in Arizona, and well, the center of this area is Phoenix. Let's look at the distribution in this strip right here for perennial. Where are the perennial rivers located or clustered?
Mountains?
In the mountains, in the green areas right here. And they're far and few between. I think this is right here is the Gila River. Intermittent is the yellow. And where are they kind of located? Close to the mountains, because again, they're fed by intermittent is seasonal, and they're probably fed a lot by snowmelt. So they're close proximity. Which kind of drainage is the most dense, or it's all this green area is ephemeral. So that's the most frequent type of drainage there is. And there's an anomaly right here. Do you know what this location is right here? That's Phoenix. That's this area right here. And the reason that here is within developed areas, most of the rivers have been channelized and controlled, so they don't show up in this classification system. Okay, this is from Google Earth. This is an ephemeral drainage, and we do see vegetation, but we don't see much sand and gravel. This is an intermittent stream. It's Canyon Largo, and we can see there's a lot of sand and gravel, so we would expect base flow. And with base flow, sometimes we can dig below the surface and find water. This Armijo actually, this is within Armijo's travelway right here, along the Canyon Largo. Again, another reference from the database, and this shows all of the springs in Arizona. The dots are actually blue, not black, but at the photo scale, they appear black. Where are the springs clustered? Again, in the mountains. And can you see some alignment on springs? There seems to be some alignments.
That's kind of a northwest, southeast.
They can be directional, but there's a better association for these alignments.
I can't see any dots. Must be drawing.
Yeah, well, it's a dark shaded area. They're so dense.
Along the river.
Right, and again, we're froze. Does anyone know any good jokes? This is, I say, this is the first time it's happened to me in 11 years, so I'm not sure what the explanation is.
So are springs year-round?
Generally they are, but they can only have short durations. So they can be long-term, but they may not last 1,000 years.
Bruce, you know about the Moapa Spring? It has a large volume of water, and I don't think they know exactly where it comes from.
I haven't researched that. I know they've got palm trees. We talked about alignments, and now you can see where the alignments are. And again, I'm a little reluctant to use the pointer, but these are drainages. So they are aligned along drainages. Okay, let's get into physics here. Let's visit the realm of approximately correct and precisely wrong. It's called concepts and generalizations. Okay. Can water flow like this? Yes or no? Okay. Can water flow like this? Yes or no? Okay, what's the reason? It's called gravity. Okay, what's the problem here? Water
It doesn't go uphill.
it doesn't go uphill. Water can't, it could flow up to this point here. So it could flow as high as its highest elevation, or what they call its head. But to go beyond this point, you're fighting gravity, and it won't go any further. Okay, let's simplify again. Let's say from the interest in springs, there's only two types of materials. And it's related to permeability. There's permeable and there's impermeable. Permeable allows water flow, impermeable says no, it doesn't allow water flow. In rock, the conduits for water flow are the fractures and the boundaries between permeable and impermeable rock layers or bedding planes. In soils, the conduits are the void spaces between the particles. Now remember the color coding. This is permeable, allows flow. This is impermeable. It doesn't allow flow. Okay, what do we call this right here? We've got rain, and then it flows on the surface. It's runoff. So this happens because we have runoff when we have an impermeable surface. And concrete and pavement are good examples, but rock and soils can also be somewhat impervious. So this is runoff. With rain, it penetrates the ground surface, and then we've got infiltration and we've got storage. So when rain can penetrate into a permeable material, it can flow and it can be stored. To understand springs, all you do is just remember this equation. Gravity plus permeability plus impermeability. So to have springs, you have to have these three different conditions. Okay, what do we have here? What kind of material is this? Okay, could we have springs here? What are we missing? We're missing impermeable. We've got gravity. We probably also live with gravity. And so water could flow in this direction, and that's the preferred direction. So it won't come out this way unless there's a barrier or an impermeable layer. Okay, will we have springs in this condition? What are we missing? We're missing gravity. We're generally missing gravity because water, if it can be stored here, there's nothing showing that's going to make it flow uphill. Okay, how about here? So what do we have? We have permeable, impermeable. It can hit here, get diverted, and flow out.
That's precisely the way Washington City springs are from the north.
And we'll see that's the way most springs are in the desert. And it's called a perched groundwater condition. And the name of the spring is a contact spring. So this is the way most springs, the reason we have springs in the desert is this groundwater condition. It's a perched groundwater condition. The water source is infiltration from rainfall. It reaches a barrier and then it daylights. Do you see any springs? Could there be springs here? What questions do we need to ask? Is this permeable? Is this impermeable? Okay, I cheated and I went to the database, and there are actually springs located here, and there are springs located here. And I'm reluctant to get the magnifying glass, so I won't. But some of you in the front row can see there's actually some green area here for vegetation, which probably resulted from the outflow of these springs right here. And this area is flat, but the perspective on the photo makes it look like it's inclined. What do you see? Armijo's travel way is the red line. This is the circled area we were looking at in the previous slide. Can you see three different rock conditions? How about tan, brown, and gray? Where would the spring line most likely occur? It's this boundary between permeable and impermeable. How come cliffs are set back so far from the drainage channel right here?
Erosion.
Right, but it's not what you think. And stay tuned, we will talk about that next week. And it's not stream erosion, it's cliff retreat. And that's the explanation for these cliffs being so far apart. How can I get information about the rock? If I want to know where the different rock types are located, or get some information about the properties, what can I use? I can use a geologic map. And what I've done is I've overlaid information from a geologic map on the ground surface. Different colors represent different geologic formations. The green area consists mostly of sandstone, and according to the map, sandstone, and we expect sandstone to be permeable. This area kind of fades out right here And this is the impermeable geology formation, but it's also interbedded with thin permeable layers right here. This area right here is limestone, and locally it can be a barrier to vertical flow. I didn't change the color coding here, but what has happened is the stream channel has eroded through the limestone and exposes another rock formation down here, but it isn't the same as this one right here. The green pins show the USGS database spring locations. So most of the springs occur in this area right here, as we expect along the boundary between permeable and impermeable. They also occur below the boundary and kind of where the slope changes, which indicates that maybe the rock materials have changed. So there might be fractures that take the water stored in this reservoir and carry it down to these points right here for discharge. And right here we have a spring area way down, but it's at the contact between the fine grained sediments right here and the limestone right here. So again, generally springs occur at boundaries between rock formations, specifically permeable and impermeable boundaries. What causes these gullies? What kind of erosion? It's not surface water. Some of these are, but most of these are caused by backward erosion from the springs themselves. That again is cliff retreat, which we'll discuss next week. Do you recognize this? Weeping Rock. What kind of spring is this? It's a contact spring. So we've got the Navajo sandstone, which overlies the less permeable Kayenta formation. So this and many other, particularly the alcoves and many other springs occur along this contact line. Let's show how groundwater can spurt from the ground surface. There is an exception to perched groundwater conditions or contact springs. Again, we've got gravity here, so the infiltration is here. This is permeable. It's called the aquifer. You've got impervious material here. You've got impervious material here. So the permeable material is actually confined between impermeable and impermeable. And somehow you've got a break in the overlying impermeable, and that's how you get a spring. So that's how come you've got a head here that's quite a bit higher, and that drives the water through here and then up through, in this case, the fissure or fracture, and that's why you can have a spring sprouting from a flat groundwater surface, a flat ground surface.
The fissure can be a fault, and this is a lot like Washington City. Most of the springs are exactly this. You see the fault line when you come down the freeway. It's where it all drops into the bucket and the road.
Right. And faults cause fracturing, and fractures are conduits for springs. Here's another example of an artesian situation where you have a fault which can be a conduit or it can be a barrier. Because where you have faulting, you have displacement, you have grinding of the rock surfaces one against the other, which gets very fine and can be a barrier to flow. But again, in this case, you've got the conduits are the fractures, you've got the rainwater infiltration, you've got water up here that can drive water up here. And so the hydraulics or gravity is satisfied and you can have a spring. Do you recognize where we are? How about the Grand Canyon? Do you recognize the Grand Canyon now? This is the Kaibab Plateau, right here. And this is the Colorado River. And there's that anomalous bend in the river. And again, this is the USGS database location for different springs. And first of all, do we see alignment right? Well, I don't want to bring in my pointer because I don't want it to freeze again. But can you see an alignment? And what do you expect to see along that alignment? Probably some boundary between a rock layer. Again, the scale and the perspective might be a little misleading, but generally right here, alignments along a line generally indicate that there's a contact between permeable and impermeable. Further on down below the surface is the red wall limestone, and I think that may somewhat store water and discharge water at its base. I haven't really checked to see which formations this correspond with. The idea is that alignments indicate contacts between rock formations.
In the Grand Canyon, you have a lot of limestone in the upper sections that dissolves, and when it cuts through that, you get sinkholes when they're loaded. If you look at sinkholes with the
Well, Steve, you jumped ahead to my next question.
okay.
How can we have all these artesian springs up here?
Sinkholes.
They're not artesian, they're sinkholes. So this right here, this plateau on the surface is all limestone. And as Steve said, limestone dissolves. And so we don't have artesian springs up here. What we have are collapsed cavities that filled with water, and they're called sinkholes. Another freeze.
So is that what Jacob Lake is? Is Jacob Lake a sinkhole?
It's a sinkhole. Yeah, look at a map on a satellite map, and you see sinkholes all over the top of the Kaibab Plateau.
Is the precipitation maybe different on how it flowed?
There are no streams coming off the top of the Kaibab. Hardly any. It's all sinkholes. It's absorbed by that.
And a lot of the water that's in the limestone can discharge through fractures in the lower rocks that are exposed in the canyon.
What's the Kayenta layer? What kind of rock is that?
Have you driven up Airport Ridge?
Yeah.
Have you driven up Fourmaster Ridge? The rock you see in the road cut is the Kayenta Formation. So you can see it's layered, and it can change with locations. I mean, the layering can change with location. Okay, Pipe Springs National Monument. Why do they call it Pipe Springs? It's got springs, but what also does it have? Pipes. So actually the springs are piped, and they're piped to Windsor Castle and to the fort area. So it's a very, yes?
I used to live at Pipe Springs, and there's an old tale that Gunlock, Hamlin, Jacob Hamlin's brother, was in a contest to shoot the pipe, pull out a new pipe, an actual pipe. And that was back before they ever had a metal pipe running for water into Windsor Castle. So it was probably, it was an old stopping place for people across
And I read that they actually lined the pipes with bark, which was kind of interesting. This is kind of a diagram. There's at least three springs right here. I don't think this has been developed.
Wait, we're not seeing it on the screen.
Yeah, we have the buffalo.
Well, let's see. Even I'll see if I can recover the slides, but what we'll see, the contact here is actually between, we have the Navajo and the Kayenta again. And so we have a contact, but this contact is actually above the spring location. And as Steve mentioned, there's been faulting can fracture the rock. And so the severe fault goes through this location, and it's fractured the rock. So the Navajo sandstone is more of a reservoir, and the conduits that lead to the springs or to the discharge area are fractures in the underlying Kayenta formation. And there's a lovely photo here showing the fractures in the Kayenta. Oh, then I think we're over, so feel free to leave any time here. But let me, if you got patience, let me try to reestablish one more minute, because I think it's not what I say, it's what I show that's of most of the interest. Well, it's not working. We'll have to ask Dave what the explanation is. But there's one other source of water, and that's weathering pits, tanks, and water pockets. Have you heard of those? They're eroded depressions, and erosion, but bacteria as well as erosion can cause these depressions. They're usually not part of an active drainage. They capture water directly from rainfall, and what's the problem during the winter? They freeze. And what's the problem during the summer?
Evaporate.
They evaporate. And there's some lovely pictures showing some of these water tanks or potholes. Have you heard of water pocket fold? Have you heard of Capitol Reef?
Yeah.
Okay, it's on the, quote, water pocket fold, so you could expect to see a lot of water pockets, or what they call tanks up there. And that, again, is a lot of them are in the Navajo sandstone. And next class, we're going to deal with geology, or geology along the way. So I apologize for the slide problems. As I say, I've never had that problem before. Well, we had that problem when Diane was here. Diana was here on that first class, and I don't know. I've got to do some research and solve that, but any inclination or, oh, one other thing. You got a minute?
They're starting that lecture next door.
Oh, what lecture is that?
Del Parsons, an artist.
Oh, I'm the artist. Okay,
Yeah,
okay, okay. Yeah, let's quickly talk about the Colorado pipeline. And again, I don't need too many slides for that. I just need some notes here. So I'm not presenting a position. I'm just going to try and list some of the considerations for arguments for and arguments against. Okay. First, I'm biased. Development means possible jobs for engineers. So my first reaction is go for it. If I wasn't retired, maybe I could find a job. But going beyond my personal bias, what about desert? Is that a consideration? Isn't it always nice to have a backup in a desert environment? What's the problem? If you build it, people will come. So if we have abundance of water, we're probably going to get an abundance of people. How about evaluating, is it cost effective? Well, this is pregnant with the admission that we have some alternatives. To evaluate cost effectiveness, you've got to have other alternatives. If you can't do anything, who cares if it's cost effective? And one of the other alternatives that is frequently discussed is conservation. What will it cost me? There's differences of opinion on that. And the bottom line is risk. How certain are these arguments? Will conservation always satisfy our needs in the future? What about climate change? So then again, these are some of the considerations that came to me. Can anyone suggest some other? Does anyone want to argue for or against? Okay, now let's go home, but please come back for geology next week. Thank you.